are in a moment, but these are resources that you need while you're programming. Everything's going to be in the browser. We're going to be using Google Colab for this workshop, and it's going to be a it's going to be like a code along. So take a moment right now and please add this folder, take these files and add them to your own drive, copy them into your own drive. We're going to be linking in Colab to your drive in order to load them into the into Colab. Does anyone have any? Everybody's able to access it. Everybody can see it and add it to their own drive. All right.
Can we put all that awesome. In like a folder?
Yeah, all of it is in a folder. It should all be in a folder in your drive. Cool. And then we're going to go to Google Colab. So that's colab.research.google.com, or you just Google Colab and it'll come right up. And just go ahead and make a new notebook in Google Colab. So yeah, starting totally from scratch, we'll work through it all together. I'm going to send a finished copy of the code in the chat in case you get lost along the way. That way, or you know, if you want to refer back to something earlier, let me drop that in the chat real quick. Awesome. Cool. So let's get started. So everybody has that in their own drive now. So we're starting totally from scratch. There's some libraries that we're going to use that are really going to help us. And so the first one is we need to import pandas. Pandas helps us work with data frames. So we're going to get in a lot of data from like CSVs and things like that. And pandas puts it into a data frame so that it's easy to manipulate the data in aggregate. And then we're also going to need Matplotlib. This is just a command that lets Matplotlib know it's in a Colab notebook, so it formats the graphs properly. This is a library we're going to be using for our plotting. And then the third thing we need is a library called Geopandas. This is probably not going to be installed in Google Colab by default, so we're going to do a command here. Pip is like the install manager for Python. All of this is, we're using Python today, by the way. Pip is the install manager for Python. So we're just saying to Pip that we're going to install this package Geopandas. And when you're in Colab, if you have this exclamation point before what your command is, all of these commands are in Python, and Colab is going to treat it that way. But if you put an exclamation point before a command, it runs it in a bash shell. So it's running it as if you were to type it into your command line. And then the last thing we need to import is Shapely. We're going to import three parts of Shapely because we're going to be manipulating points direct. Actually, I think we don't need line, string, and polygon. Just import point. So because we're working with geographic data and that's geometric, we're going to need to work with points. And Shapely is a library that deals with geometries. It works with Geopandas. So we can go ahead and run this, and all of these will, the pip will install Geopandas, and we'll get all of these in. Awesome. So let's make a new code block. And we're going to need those assets that I linked in the chat. So if you've added them to your own Google Drive, now's the time when we want to get them out of your Google Drive and into Colab. So Google has made this easy for us. We're just going to do from google.colab, import drive, and then, yeah, there we go. And then drive.mount. And we're going to mount content and then drive. So we can run this. And what's going to happen is it's going to ask you to go to a URL. And I'm going to open it in a new window so you don't all see my password. It's going to ask you to open to sign into your account. And then it's going to give you like a one-time code that you can enter into Colab. All right, so I'll enter in, well, I guess you all see the code anyway, so, but it doesn't matter anymore. Awesome. So now we've mounted our Google Drive as a drive on the virtual machine in Google Colab. For those that aren't familiar with Google Colab, this is a Jupyter notebook that's running on hardware provided by Google. So actually all your code is running on a really nice virtual machine that Google has provided. It probably has a GPU, so everything runs nice and fast. Awesome. So the first thing that we need to do is import some data. So what I'd like to do for this workshop is look at how insurance rates and coronavirus testing might be related. So Johns Hopkins University does a lot of coronavirus statistics. So we're going to grab their coronavirus data for today. So I'm just going to do JHU and pd.read CSV is a command where we can put in any URL if we want to put in a file path or we want to put in a URL that allows us, we can read in CSV data. And then I'm going to copy in a URL. You can copy in actually in read CSV, it doesn't actually have to be on your file system. And let me copy this URL in the chat and you can use that too. It can be a URL like on the internet. You can grab data from there too. So I'll run that and then we'll have Johns Hopkins University's data for yesterday for the United States. So all of the counts. So let's do jhu.head to show us what was in the data frame that we just imported. Awesome. So we can see we have by state, we have confirmed cases, we have deaths, we have recovered, we have active cases, and then we have FIPS code, which is related, that's the Federal Information Processing Standard. We'll use that in a moment. And testing, stuff like that. So this is a really great data set. Awesome. Is everyone here, by the way? Did anybody have any trouble importing from Google Drive? Okay, so now we're going to actually use the data that we got, that we put in our Google Drive. So what we put in our Google Drive are a bunch of files called shapefiles. There's a couple of different ways to encode geographic data that like GIS and software like Geopandas understands. And one way is GeoJSON, which was used in the last workshop, and another way is a shapefile, which is an encoding of different features. It's sort of like a data frame actually, except it's encoding geographic features. But there's a reason why you can't just like put in a bunch of points and say, oh, like these are the places that I want. And it's because like when we're mapping, it's impossible to take a sphere and put that like to cut apart a sphere and make it a flat surface that's like a square. You can't take a sphere and make it into a square plane. It's just not possible. So we have projections, and so the shapefiles have information on the coordinate system, the coordinate reference system that we use. If it's a coordinate reference system, like if it's a flat map, or if it's a coordinate reference system, coordinates on a sphere. So the shapefiles have that information in them. And when we load them up, you'll see like they're polygons on a coordinate reference system that the shapefile has the information for. So let's get in some of this data. So we're going to load in a map of the US, states, and that's part of the data that I included. So we're just going to do GPD. GPD is Geopandas, read file, and then we're going to go into our Google Drive. So we mounted content drive, and then all of your Google Drive is in this folder called My Drive. And then whatever folder you put it into, I put it into a folder called GIS Workshop. And then we're going to import the file GADM36 USA1.shape. GADM is an organization that makes shapefiles. So actually, if you Google GADM, you can go there and get shapefiles of like any country. It's a really awesome resource. I always use it when I'm getting shapefiles. Yeah, they have shapefiles of like every country. Another source you can use is actually data.gov has a lot of shapefiles of different states, which is pretty cool. So let's load that in. GPD is not defined. Oh, I've installed it, but I forgot to import it. Sorry. Cool. So let's run that again, and it should work. Let's try this again. Awesome. So we have this USA map, and let's see what it looks like. So all we have to do is do USA.plot to get like a basic plot, and it's going to look terrible. Let me try. Sorry. There we go. Okay. So if you're having trouble, try Matplotlib inline. That might fix it. Yeah, it looks bad because one problem is because of the projection, Alaska has some islands over here, so it's stretching out the figure. And also Hawaii is on here. So, and we can also make this figure bigger by using Matplotlib. So let's do something first. Let's get rid of Hawaii and Alaska, so we're just focusing on the continental US. So I'm just going to do USA and USA.loc. Loc allows us to like filter out entries on our data frame. So USA, the column that we're looking at, if we do USA.head, we can see that this is actually a data frame just like this one. It just has geographic data attached to it. So you can see like we have a name and like the names of different states and the name of the country. But here we have the difference between a Geopandas data frame and a regular Pandas data frame is that we have this geometry column and we have these polygons. We can represent shapes as polygons or multi-polygons. We can also represent just points and lines and polylines. So let's get rid of Alaska. So the column for state names is name 1. And we just want to say where name 1 does not equal Alaska. And then that will get rid of it. And we can do the same thing for Hawaii. Awesome, great. So now when we plot again, and I'll make it bigger this time. So I'm just going to make a plot here, an axis object, which allows us to have multiple like plot operations on the same axis. And I'm going to make like a big figure. So what we have this fig and ax here. In Python, you can actually separate by comma different different return values that are going to come back. So then we can do usa.plot and we can put it on those axes that we created so it's nice and big. There we go. Great, the US, hooray! Awesome. So let's move on. Let's get in the COVID data that we're using. So I'm just gonna make a new data frame called USA COVID, and we're gonna use the merge operation. We're gonna merge our existing data frame with this data frame. So I'm just gonna say USA.merge, and then we wanna merge in the John Hopkins. JHU is what I called it. And then we need to decide what attributes we're going to merge on. Because we're taking two data frames and putting them together, we need to have a column between them that's the same so that records from one data frame can be matched up with records from another data frame. Can I scroll back up a little? Sure. Robert, do you have a specific question? All right.
Yeah, when I ran the one that you have marked as 17, something went wrong.
This one?
Yeah.
Did it give you a specific error or did just nothing appear?
Yeah, it says attribute error module Matplotlib has no attribute subplots. Which is interesting.
Yeah.
The code looks the same, so.
Okay.
It's okay. Go ahead and proceed. I'll see if I can't figure it out.
Okay.
I just wanted to make sure I had the same.
Yeah. Yeah. I don't know. Make sure it's subplots, plural. Make sure that's not misspelled because I have misspelled it before as subplot, not plural, and then that doesn't work. So perhaps it's that. So we have two columns, right? So let's look back at our columns, and we have one column that, like in our Johns Hopkins, these are separated by state. And like, let's look at what columns are common. We have state names here, and we have state names here. So in order to merge our geometry data with our epidemic data, we should merge on the column province, state, and name one. So let's do that. So all we have to do is left on is the parameter for the left one. So the left one refers to what's behind the period. So let's pass in the column name, which is name one. And then we need to pass in a right on. So let's pass in province, state is the name of that column. And then let's do a left, a left join. So it doesn't really matter because they all have the same data for this one. But what that means is that like everything, like we're going to pay attention to what's on the left data frame. We're going to drop things. Like let's say we had like an international data set and there were like country names in here alongside the states, or like Canadian provinces actually. Let's say this were for the US and Canada, but we only have a US map. So what left join will do is say we only care about the rows that are in USA. So if it's not in USA, just drop it. But if it's in both, then you can put it in. So we can run that. And now we've merged the data sets. Or we haven't. Oh, sorry, I made a typo. Cool, so we've merged our data sets. And then like, let's just check that it worked properly. Yep, so we have name 0. We have the geometry, and at the same time, we have our like our coronavirus info. Awesome. That's exactly what we wanted. And they're all joined, like we can see, like Alabama is joined with Alabama, Arizona is joined with Arizona, Arkansas. Awesome. So that's exactly what we expected. So let's make our first plot. Unfortunately, Geopandas makes it really easy to make plots of geographic data. So let's make another figure and axis. And we can set a fixed size here. You can also set things like a title in here. There's lots of parameters you can pass into subplots. And then let's plot our existing data. So we merge these together. So, and let's do by confirmed cases. So this first parameter is what we're going to be plotting on. You can also do like column here, but I'm just going to pass in directly the data frame column. And then we need to pass in our axis. This is really useful, by the way, for when you need to do multiple plots. Like we're going to plot like points on top of our map. This is really useful for that. Let's add some color to the edges, just so it's easier. Like we just had like a sea of blue. So let's put some lines in there. Let's add a legend. This will automatically add like a color bar that will tell us like what the quantities are associated with. And then we're going to add a color map. And this is one that I like. Then let's run this and see what happens. And why did it fail? Geo data frame object is not. Oh, oopsie. Sorry. You have to call plot. My mistake. Yeah, so you're calling plot on the geo data frame object. So this is calling Geopandas's version of plot. Can you all see my code all right? Like, awesome. So, like, do you need it made bigger? So we can see we have a wide range of number of coronavirus cases. We're looks like in third place. Go Florida. So awesome. This type of map, by the way, fun fact, this type of map is called a choropleth. Choropleth. So if you're looking it up, like if you're looking up how to do it in Geopandas, the instruction or the documentation will refer to it as a choropleth too. It looks like the map makers or the people who made the shapefile looks like they joined the Great Lakes region. They had some error in there. So if you have like a software like QGIS, you can actually draw points to fix it if you were so inclined, but we're going to use a different shapefile too. Awesome. So we have our first map. Cool. Are there any questions up to this point? Did everybody get a map? This is not accounting for different state populations, so that's something we can do. All this is doing is taking number of cases and putting it on a map. Can we jump back up a few lines? Okay. Hey, Rob, do you have is there a specific part?
Yeah, I just got I followed what Dylan said and I got the thing working. My imports were messed up.
Okay.
Is that the only thing you did after? I kind of zoned out for a minute while I was trying to fix it.
Yeah, all we did was we merged, actually,
Oh, I
if you
missed the
got
merge. Okay.
Oh, you missed the merge. Yeah, so we merged the data together and then so that they're all one geodata frame. And then we made another plot and we made a map.
Okay. Yep. Go back to the merge for a minute so I can. Oh, is that the full source? Then I can stop barging in.
Yeah, sorry. There's the finished version in the chat.
Okay.
Looks like
Never
Dylan just
mind.
reposted
Proceed
it.
then. Thank you.
Okay, awesome. So cool. So we can do some stuff like we can bin these. Like if we didn't want to have this range here, because it looks like honestly there's a few states that are like have a lot of cases, and there's a bunch of states that have like a moderate amount of cases, and there's a bunch of states that have like no cases. So you can make a map that reflects that. So we can just make an array of like the values that where we want to bin, like what are our cut points for our bins. So you can like say 0 cases, and let's start at like 100,000, and we can go up to like 500,000, and then we can cut again at like 700,000, and then we can cut again at like 1 million. Awesome. And then we can just, the labels can be whatever you want, like they can be text labels, but let's just do 1, 2, 3, 4. It'll make it easier to map. And then we can make a new column in our geodata frame. We can call it like bins. And then we're going to use a function called pd.cut, which is the pandas like binning function, equals .cut, and that's going to return an array, or I'm sorry, a data frame column of what bin each column belongs, each row belongs in, excuse me. So let's do again, let's pass in our first parameter is the number of our cases, and then we also need to pass in our bins, and then we can pass in our labels. Cool. So we've made some bins. We've made a new column called bins. We can test it. Awesome. So let's see. Yeah, we've got bins here. Fantastic. Okay. So let's make a new chart that shows like what bin, I'm sorry, a new map that shows what chart, what bin, what bin each state is in. So let's make another figure. And then the column I'm going to pass in this time is the actual bins, rather than the count. So, and then we associate it with the axis. And then the color map that I'm going to use here, let me show you real quick where to find all of the color maps. So if you like, let's say you hate, you hate blue, like you just, that color, just, you can't stand it. Geopandas has a ton of color maps that you can choose from. So, and we can go in the documentation and find it real quick, just so you see it. Yeah, by the way, chloropleth. Colors, where is it? Sorry. There's a chart. Okay, well, take my word for it that you can choose from a ton of varieties of color maps. Go ahead and plot this. Awesome. So you can see, I guess this one's a little bit counterintuitive because green is not good. But yeah, we've binned it so that the states with we have like discrete colors for the states. So you can see like precisely which belongs where. Awesome. So next up, what I'd like to do, I told you that we'd like to look at insurance. We'd like to look at insurance data. So I have actually a data set of the percentage that includes the value for the percentage of a state that I'm sorry, the percentage of a county that is uninsured. which is kind of interesting. So let me copy this link into the chat because you'll need to read a CSV from it. Cool. So I'm just going to make a new data frame here, and we're going to read in a CSV. And let me paste in the link real quick. Okay, cool. So let's make sure that that worked. Oops. Let's see what we got here. Awesome. So this is data from 2017, by the way. It's a little bit older, but I think it's still pretty good indicator. And we have this FIPS code. The FIPS code is what's going to allow us to associate, because there's like tons of different counties and some of them have the same names. Also, merging things on names is like always terrible. If you're ever dealing with country data sets, like this happens all the time with shapefiles, is nobody who makes shapefiles can agree on what countries are called. And nobody who makes data sets can agree what countries are called. There's like historical names for countries. So merging on country names is always terrible. Also, sometimes colonies or former colonies, I guess, well, they're still part of the country now. They're not colonies any. I guess they would still be colonies, but foreign territories to countries like get written as that country. Like French Guyana sometimes get written at France, or like French Saint Martin, or yeah, the Netherlands also has like islands places. So it happens a lot where the names are not good to merge on. Cool. So we have this is the percent uninsured. PCTUI is the percent uninsured in a county. Cool. Awesome. So we've got our insurance data. I also, this does not include counties in our map. The shapefile that we used previously does not include the shapes for counties or the names. So we're going to need to import that too. Don't worry, it's in the content that I put in the folder. So let's pull that in. Remember, it's content drive, and then my drive, and then whatever folder you put it in. Okay, cool. Let's pull in our counties. Great. We're in. Let's see what that data frame looks like. So cool. So we've got a name, we have a state name, and then we have this FIPS code, which we can use because this insurance data set also has a FIPS code, which is awesome because we don't need to like hope that they capitalized and spelled Lake of the Woods the same, or penned Oriel or O'Reilly. I don't know. Okanogan. Yeah. And we have, of course, the geometry for all of those. Awesome. Let's also remove Hawaii and Alaska from this data set. Sorry, Hawaii and Alaska, but maps look better when they don't have those states. So we're just going to do the same thing we did before. We're going to use loc, and then we're going to pass in our condition. Cool. Just do the same thing for Hawaii. Awesome. Let's plot this just to make sure that we have it right. Cool. So you can see, like, if you kind of squint, that all of the counties, the states are broken up into. Awesome. That's what we were looking for. So Before we can use the FIPS code, by the way, let's make sure that they're the same data type. So this, like, if we do D types for insurance, that'll, oops. Oh, sorry. Hey, Brett, how did you do this in your just now that workshop? Okay, that's fine. Well, I know these data sets. Yeah, data frame, D types. Okay. Oh, it's an attribute. Sorry, it's not a function. Sorry about that. You can see CFIPS here is int64. If we do that on our USA counties, because we're going to merge on that in just a second, and we do D types, we can see it's an object. We don't want that. We want to be able to merge on we want them to both be an int so that they can be the same data to merge on. So real quick, let's do USA counties and let's get the FIPS and let's use as type. Awesome. So now, and we can try this again. Yep, that's what we expect. Also, PTC UI is something we're going to need, but it's an object. We're going to have to fix that. We'll fix that in just a second. So the first thing is, I noticed while I was looking through this data set that percent uninsured, they didn't actually leave the values null if they didn't have any data for that specific county. A couple of counties they didn't collect data for. So we're gonna need to correct for that because currently they just put like a string value in there. They put in like 3 spaces and a period. So let's just get rid of all those because they're not useful information anyway. So I'm just going to say like where it's equal to this string, they put in, I can copy this into the chat too. Like this is the string that they put in there. That's not helpful. So it's 1, 2, 3 spaces, a period, and a 1, 2, 3 spaces, a period, and a space. And that's not helpful data. So we can get rid of all of those columns because they have no data anyway. Yep, that worked. And then let's just get the 2 columns that we actually need. The data set actually has a ton of columns in it. And I know that we only want this percent UI uninsured column. So let's just get the data frame. We want the FIPS code. So CFIPS was the name of that column and PCTUI. And then that should be good. Let's also change their data type because if we look at their data types, right now, we'll see that they're objects. Well, one's an int and one's an object, and we don't want this to be an object. We want it to be a float value. So in order to fix that, let's just do, let's just get that column and use as type. And make it into a column of floats. Is everyone here with me, by the way? Does anybody have any questions up to this point? Okay, awesome. So let's go ahead and merge those columns together. So insurance, let's do, so we want to merge it with the county data. We want to call merge on it. And so what we're going to merge USA insurance with is insurance, and we're going to merge left on. Left on refers to what's in USA counties, and the name of that column in USA counties is FIPS, FIPS. So left on FIPS, all capitals, right on, and then the insurance data set called it CFIPS. And we also want to do a left merge. That way, you know, all of our counties stay the same, because what will happen is if we do a right merge, like if a county didn't have data and we remove that column, it's also going to remove the column from the, I'm sorry, and we remove that row, it's also going to remove that row from the geographic data. So we'll have holes in our map. But in the opposite case, in the case that we have a shape that we want to plot, but we have no data associated with it, it's no problem that data is just left as NA. So we can go ahead and merge that. Awesome. Let's make another figure. And so I just made another figure, and we're going to call the plot function. And we can pass in the column as a string, by the way. So we'll pass in the column name. We want a graph, PCTUI. We want to make a graph of the uninsured people in a county. Let's make it, we're going to make another chloropleth. So, and we have our color map. Let's use the same one, the PUBU. If you add _R to the end of a color map name, it reverses. So like up here we had, if we have this color map like light to dark, if we reverse it, we can get it dark to light. Oh, sorry, I didn't see the chat. What is the syntax where you put an expression in the brackets? Good question. So this this loc operator, let me explain like actually what's going on here. So if I make this let's just see what's printed out when I do what's inside of those brackets. Not equal to that. Oops. Sorry. Oh, I can't use this because I already removed those. There's none in there. That's okay. Let me use a different example. So we have the state names. When I went to let me get to your question just a second. Sorry. Let's say like we want to get rid of another state. Let's say like we want to get rid of Florida off of the map, or we want to only include Florida on the map. So we could do like USA insurance dot, what is it, name, the column name is state name. When we do that, it will give us like a data frame where like these are true or false values based on if it's in that column. So when we do loc, we're actually like passing this array in, and we're saying like these indices where this Boolean is true, those are the rows that we want. So like if I do USA insurance dot loc and I do this, it will return to me all of the counties that are not in Florida. Yeah. So yeah, that's all. We're just taking this. This is just returning like a column of bool values for whether it is or is not Florida, whether it is or is not that this condition is true. And then loc just says, okay, the columns where this condition is not true, actually get those columns, and then we just assign that to a new data frame. I hope, does that answer your question, Rob? Okay. Okay. When you print insurance.pctui as type float, I got an error that said it could not convert string to float. Make sure, did you make sure to get rid of the string values inside, like to get rid of this 3 spaces and a period and a space? Just get rid of those columns. Because if there's those values in there, it will not be able to convert them because those cannot be converted to floats. Okay. I'll move on. If you want to ask again a question, you can, or if you still are stuck, let me know. Cool. So let me get back to remember what I was doing. Oh, right. So we were going to make a map of insurance, of course. So we were going to use this reversed color map, and then let's pass in the axis again, and let's add a legend just for fun. This might take a little bit longer because there's so many counties, by the way. The more features that your shapefile or your JSON file has, the longer operations usually take because it has to operate and plot more features. And so like in our earlier map examples, we only had 50 features, like because there's only 50 states. But in this situation, there's like 20 to 30,000 counties. So there's a lot of features that it has to process. Awesome, hooray, we have a beautiful map. And you can see what counties have high rates of uninsurance. So like higher corresponds to less people have insurance versus lower rates where like many people are insured. We can see like a lot of Texas has high rates of uninsured people. Also, South Florida has a bit higher rates of uninsured people. And in the South, there's relatively higher rates of uninsured people. So let's see how that affects coronavirus cases and testing. So let's compare this map and let's create a visualization that combines both of these sets of statistics. So I'm going to pull in March COVID data because I think it illustrates really cool, like it illustrates something, like we did this back in March and it illustrated like the relationship really well. So I'm going to pull that in as well. And we can also use today's COVID data to see if it still holds. So again, I'm going to pass a link. We're going to download another CSV. We're just downloading off of Johns Hopkins GitHub. So I'm going to drop a link in the chat, and you can download off of Johns Hopkins GitHub. This is coronavirus data from March 23rd, when it was still a little bit earlier in the outbreak. One thing we are going to need to do, because not all of the counties, or not all of the places in the data set are going to have FIPS codes. First of all, let me actually copy in the code. So I'm going to make a data frame called March COVID, and I'm going to do a read CSV, and let me paste in that link and pull down that data set. Awesome. So let's just do a dot head just to see what this data frame looks like. Awesome. And so we have like confirmed cases, and by county, by the way, and or deaths and recovered, and active cases. So one thing is that there are some ones in here where there's not a county associated with it. So let me illustrate that. Let me just print out the ones that aren't. So look, you don't have to do this part. I just want to show you. March COVID and that FIPS, that is, I think this should work. Awesome. So there are there are like 273, because it contains some international data where there's not a FIPS code associated with it. So like there's a couple of counties in Utah. There is a like correctional facility in here. There's also this data set also includes like the Diamond Princess cruise ship, when like that part of the epidemic was going on, when that was like a separate, they considered that like a separate area. Also, there's some like Guam, I don't think has FIPS codes. So let's get rid of all of these where no FIPS codes exist. So I'm just going to say March COVID is equal to, and they went over this in the previous one, but we're going to do drop NA. We can just say we want to do it in the FIPS column and not drop NA for like the whole data set, and then set the axis to 0, and that should drop it out. The other thing we want to do, because the FIPS code we already discovered is a object, it's treated as a string. We want to treat it as an int when we're merging. So we'll just say like, you are now an int, we say so. Awesome. So let's merge our insurance data that we already merged with our geography data. Let's merge that with our March COVID data. So I'm going to make a new data frame, just USA Insurance March COVID, just to try and keep it together. And we're going to merge on the FIPS codes again. Fortunately, they have the same name now in both of them. We'll do a left merge again. Usually you want to you want the merge to be on whichever one is your geographical data. There are some other things that we have to do. So let's, I think we've already done this by getting rid of things with no FIPS codes, but just to make sure, Oh, I might have done this out of order. That's okay. Oh, I did. Okay, that's okay. So let me back up. I'm gonna take that data frame that we had before with all of that data that included areas outside of the United States, and I'm gonna restrict it to the US. So we know that there's this country region column we can see here, and we can just say where that's equal to US. And then also, one thing we need to do, because we're going to want to graph points, what I'd like to do is something where we see the point, like we see the insurance data as like colors on a map, but we see number of cases as like dots that are bigger and smaller. So like where there's lots of cases, there's like a big dot, just so that we can associate these two types of data with each other, usually in a visual, in a visual. So we need to convert, we have in our COVID data, latitudes and longitudes, but we need to convert this into geographic data. This by itself is not geometry. This is not points. We need to make these points in space, or points on a plane. So that's not too hard to do. So let's take that. So we have this, let's make a geometry is what we're going to be doing. So what we can do is we can use the zip function and we can create point objects. Remember I said that we imported point from that library, that geometry library. So we'll just do point xy for, and we'll say xy in zip. Zip is a function that just makes like tuples, I think, out of like multiple, like for instance, latitudes and longitudes, and it'll make tuples out of it that can be then combined in this like xy value. So the one column is long, and they use an underscore, and then the other column is US lat. Great. So let's just make sure that works. Okay, great. So we have points now. And then let's make a geodata frame out of it. So this is, we're going to make it into geographic data. We've made it into a geometry because we've made them points. Now let's turn that into something Geopandas can work with. So we're going to make a new geodata frame here. And we're going to pass in the US data. This is the counties is what we called them. US, I think. Yes, county. Oh, I'm sorry. No, we're right. We're making a geodata frame. We're associating this data with it. Sorry. And then we're going to associate it with that geometry that we established, which is the US March COVID geometry. So we're taking this data. This is, maybe I should name it something better than US COVID. I'll name it so that it's a little bit more clear what's going on. We're going to take this data, this COVID data from March, that's only for the US, and we're going to, this is like our data portion of the data frame, and then we're going to pass in this geometry that we created with the latitudes and longitudes from each of those. There's a couple that we want to get rid of, like there's some values that we should get rid of that are in the United States that we don't really want to graph. So I'm just going to make an array of the names of things that we want to get rid of. So the Diamond Princess was one thing that was in the United States, or it was considered part of the United States. Also both of those cruise ships You can just copy this from I'm just going to copy this from my finish, and I'll paste it into the chat so that you can copy it in, because it's a lot to type. I'll paste this into the chat, and you can paste this directly into your Colab, or you can look at my finished code. Like Guam, we don't want to include that. Puerto Rico, because we already restricted our map to the continental United States. Northern Mariana Islands, we don't need that data. Not that those places are not important, but so let's take our data frame and get rid of those points. So I'm gonna do a loc, and I'm gonna take out, so this is like this tilde here is like a not operator. And then everything that's everything that the province state name is not in this list is what we want. So let's call province state, and let's do is a function that we can pass in like an array and say like, are any of these values in this, and then this tilde here is gonna be like a logical not that's gonna say, well, if it is in here, then that's, if it's not in this list, then that's something that we want to include in our data frame. And then we can fix the FIPS codes. Sorry, I did go out of order. So I'm just going to take the data frame, and I'm going to do drop NA, just get rid of those values. And I'm going to do the same thing that I did above. I just did it too early. Awesome. So we've done like the necessary pre-processing to take our latitudes and longitudes and convert it into geographical data. Is everyone with me so far? I know that section like is a little bit much. Awesome. So next up, let's make our actual map. So Fig 5, let's make a new axis. And this is where this axis comes into play, because we're going to make we're going to plot twice on the same thing. So we'll make that, and then we'll take our data frame. Like this is our COVID data frame. We don't need to include the points just yet, because we just want to plot that insurance. So we're basically right now replicating the map of insurance that we made above. So let's pass in the column, because this is a base for the dots that we're going to put on top. Let's just make sure we've got this part right. Let's see. Oh, it's going to take oops. I've got to put in plot. Actually, let me put the dots on, because it's going to take a while to run. So we've made this geo data frame. And if I put in another code block, I can show you like what the actual, like we can run, because all of these are data frames. We can run head on it. And you can see like we have point data associated. Yeah, see like we have this South Carolina, like this is the location, the latitude and longitude, and then we've taken that and we've made a geometry data out of it, which is important if we're going to use Geopandas to plot it. We have to. So now we can take that and we can plot all those points. And then I'll make the points red. We can make them whatever color we like. And then we're gonna pass in this parameter called marker size. And you can actually pass in values and make each marker, each dot, a different size. So let's do like just by number of confirmed cases. And then, because the dots are going to be really big, I'm just going to multiply this by a scalar and just make the dots smaller overall. And then we can run this and wait for it to complete. It's going to take a moment to complete because we're mapping a bunch of points and also a bunch of features. So while we're here, are there any questions? Yeah, this command takes a while to run. The more features you add, just like things get longer and longer to actually to plot the maps, because we're plotting like pretty much like 60,000 items, which is pretty cool. Ooh, here it comes. Awesome. Cool. So we got the map we were looking for. Cool. Yes, hooray. And something that was pointed out to me by like a professor in the political science department is like a lot of the areas where thank you, a lot of the areas where there's low insurance rates, there's high uninsurance rates, there are also low confirmed cases rates. And this was early on in the pandemic when we were concerned about like, well, are people, testing wasn't like quite there yet, and were people afraid to get tested because they didn't have insurance, for instance. And you see like, now this is not associated with population. So if we really wanted to study this, we would say like, oh, this looks interesting. It looks like there's like low amounts of cases in areas where there's low insurance rates. We should see if population is associated with that. Because like a lot of counties in Texas, some of these counties up here have like very low populations, but like areas, I'm pretty sure like this is Houston. There's areas here where there's large populations, but there's comparable to like they're in like the top most populated areas, and there's very low numbers of cases, but there's also high rates of not being insured. So this was an interesting observation that we had back in March. I'm not sure if this still holds because the testing has gotten better, and I think like free testing has gotten more accessible. But what we could do is like, if we wanted, because this is a daily report, we could just run all of these lines again, just change this date here to be like to yesterday and see what happens. To change this map if we wanted to make that observation. I can do that real quick. Well, if anybody has questions, now is a good time, like we can discuss, or if you got stuck. I'm curious though if this, I haven't tried this. Let's see what today's or yesterday's looks like. Oh. Oh. Yeah, I haven't tried this, so there might be some like data related issues. I don't know. It looks like they've changed the data set as well, like the structure of the data set. So there might be length of values. Oh, let's get rid of anything without a fibs code. Maybe that would do it. Oh, I didn't define it. Okay, that's fine. That's something I'll have to like play with more in order to see. Okay, so there's no questions. There's no open questions. So yeah, you've made your first map using Geopandas. Like these shapefiles, like this is actually like what a lot of social scientists would use for this sort of thing. So yeah, pretty cool. It's interesting. We can make like observations. Yeah, sorry, I changed this around. Let me put it back. You can also see my like actual good code. Um, oh, no problem. Did you have a specific question? Swahila? Sorry if I'm not saying that quite right. I can also show you real quick, like there were some measures like data science, like spatial data science that don't really work well in they don't work well on like Colab notebooks because there are like issues with installing packages. You have to use like apt get. But it is kind of still interesting. I can show. I did like a paper on looking at like terrorism across different countries. There's actually an organization that does like takes a record of every terrorist event that happens in the news. Rob, you can use R to do some of this, but Geopandas is not in R. Python is really what most people would use because actually most of the tools like that people have been using for a long time, like there's a software called ArcGIS. That's actually just a wrapper for Python. There's a company that called Esri that started GIS, like made kind of modern GIS software. And they created their own framework and then they built it using Python. And then Geopandas is an open source GIS framework to use. But yeah, people use R. I really heavily prefer Python for this. I can show you like one real quick thing. Like I did I was looking at financial globalization and terrorism. So I can show you my like previous thing that I did. Yeah. So I was looking at like financial globalization. Can you see it? Yeah, I think so. I was looking at financial globalization in 2015, and you can actually create like hot spots and cold spots. So the first thing, like you need to create continuity graphs. So like this is, are things touching each other? Like are countries touching each other? And yeah, you can let me go down. Sorry. This is like just an interesting thing, but there's like measures of spatial autocorrelation. So like the question is, are places where financial globalization is high or low, are those places clustered together? And the answer was yes. I ran a statistic called Moran's I, which is a measure of spatial autocorrelation. And it's similar to like when you do like a linear regression, in the sense that like you get this like a slope almost. And you can see like this is a p-value similar to a p-value if you're doing other forms of regression. And like, yes, like this says there's a statistically significant spatial autocorrelation, as in the value changes depending on where in the world something is. Like the value, there's clustering in the value pretty much. And you know, this is the slope of that. You get like an I value, which is really interesting. You can also do local measures of spatial association, and that's where you can get a really cool graph of like hot spots and cold spots. So I did a graph, a map of hot spots and cold spots of financial globalization, and it's really interesting. Like you can, and I also did one of terrorism, where you can see like a map of like areas where terrorism is higher. That doesn't necessarily mean it's like high. It just means that it is higher than the surrounding values. So like, you know, Australia, and also we have to keep in mind that like places will have like higher or lower values also depending on like the number of places that are associated with that place. When in the graph that I showed you, like the number of places that they're touching. So there are some places where there are cold spots. There are some places where there's like a donut, in the sense that like there are many areas surrounding it, but it itself does not have high values. And there are areas where like there were higher rates in that country than like surrounding countries. The other thing to keep in mind, though, is that this was based on public news reports of terrorism. So it was like a data set of all public news reports of terrorism, and countries have different amounts of press freedom. Like we can't necessarily say for sure that like this is the number of terrorist incidents that happened in a country. I think financial globalization is a better measure, because those are like more publicly. Financial globalization is based on like statistics from the World Bank. So like there's like highly financially globalized areas, and then there's there were some areas of like low financial globalization, which is interesting. And then there are areas where these are diamonds again, which are areas of high financial globalization that are surrounded by areas of low financial globalization, or areas where it is a not significant. But again, not significant doesn't mean that you're not highly financially globalized, because like the United States also has not a significant relationship. It just means that it relative to its peers, like relative to the places touching it, it's not a hot spot or a cold spot. It doesn't have like a special, you know, status. Yeah, that's all that I have to share, I think. Are there any questions?
Is there any like specific advantages you see of using GeoJSON or shapefiles, or just like if you were just starting some new project or something and had the option between the two? Is there like a specific one that you'd recommend just because it's a much easier format to work with?
GeoJSON probably is easier. GeoJSON is JSON. So like if you're, you know, familiar with JSON, shapefiles are proprietary. I guess, I don't know if they're proprietary, but they're a file format for proprietary software. They are the file format that that ArcGIS uses. So the reason why you might choose one over the other is like a lot of political scientists use ArcGIS. So like if you want maps made by, or geographers also use ArcGIS. So like there's a lot of map data available already as shapefiles. So you might choose to use it for that reason. Shapefiles also have other like they're easier to use if you're working with a team that like uses these desktop softwares. If you're just working by yourself, like it doesn't matter so much. But if you're working with like a team, like you're working in a class that like uses, or you're working with people that use ArcGIS, and you're wanting to do like you want to do analysis using that, you'll have to use the shapefiles. I would say like government a lot of times uses shapefiles just because they all use ArcGIS. Like if you're using government data sets, it's probably they used ArcGIS.
Okay, cool. Thank you.
No problem. Any other questions? Cool. Also, watch the debate tonight, by the way. The debate's happening like right now.
Just started,
so,
yeah.
Yeah.
Also, remember to do the feedback form. The couple of people that are here, please do the feedback form. We really could appreciate it. Thank you, Robert.
Awesome. All right. Thank you all so much.